Let's take a look at exam 3, problem 1. So here an alpha particle, which is just a helium++ nucleus, i.e. 2 protons and 2 neutrons, and has a total mass with a total mass of 6.64 times 10 to the minus 7 kilograms, is moving along at a velocity of 5 times 10 to the 6 meters per second when it enters a magnetic field, strength B equals 0.5 Tesla. So if the particle's velocity is perpendicular to the magnetic field, what is the force exerted on the alpha particle? Well, the force is pretty easy to get, pretty quick to get. We just grab our equation, right? QV cross B. Let's stick it in. Oh, not like that. All right. So QV cross B. Well, Q is what for this? Q, because it's helium++, right, is 2 times 1.6 times, right? 2 times 1.6 times 10 to the minus 19th coulombs, right? 1.6 times 10 to the minus 19th coulombs is the fundamental unit of charge. Electrons is minus this, proton is plus this. So our total charge here is just 3.2 times 10 to the minus 19 coulombs. We have our velocity of 5 times 10 to the 6 meters per second. We have our magnetic field of 0.5 Tesla. We're told in part A that they are perpendicular, so the cross product is just QV cross B. So in the end, we have force of the magnetic field is Q naught V B, and that gives us 3.2 coulombs times 5 times 10 to the 6th meters per second times 6.44, times 0.5 Tesla, right? That's our force. That's part A. So what does that turn out to be? So equals 3.2 e to the minus 19th, 5 e to the 6, and 0.5. And our total force is just the product of those. That times that times that. Total force is 8 times 10 to the minus 13 newtons. Oh, not in math mode. 8, 10 to the minus 13 newtons. All right, so that gives us our force. That's part A. Part B, what is the radius of curvature of a circular path it takes in the magnetic field? So we have on one side force equals QVB. That's the force from the magnetic field. And now it's going in a circular motion. What's the force that keeps it in a circular motion? mv squared over r, right? mv squared over r. So we've got QVB, we've got mv squared over r. These are equal to each other, right? Because the only force being exerted is the force from the magnetic field. So if we solve for r, r is mv over b, right? R is mv over qb. So 6.64 times 10 to the minus 27th kilograms times 5 times 10 to the 6th meters per second divided by the charge, right? 3.2 times 10 to the minus 19th coulombs, and the magnetic field 0.5 Tesla. Okay, let's see if we can calculate this. So we have 6.64 e minus 27. I've already got the 5 times 10 to the minus 6. I've got that, 3.2. So it is the mass times the velocity divided by the charge and the magnetic field. So 2.8 times 10 to the 1 are 20.8 centimeters, right, is our radius, equals 2.08 times 10 to the minus 1 meters, which is 20.8 centimeters. And that's the solution to part 1, problem 1.